for joining us. Today we'll explore multi-clusters in Kubernetes and we'll see how can we easily connect workloads running in different cloud vendors using an overlay network provided by KubeSlice. And then we'll see that how these workloads are feeling, that they are sitting beside each other. Quick introduction about me. My name is Yachika. I am working with Infra Technologies as a senior product engineer. I'm a creator and a maintainer at KubeSlice. And from last couple of years, my interest is basically developing in Golang in operators and computers. This is my co-speaker.
Hey everyone, my name is Rahul. I work as a product engineer at InfraCloud and I'm a maintainer of KubeSlice and yeah, let's go ahead.
Okay. But before we jump into the presentation, I would like to know that how many of you know about multi-cluster in Kubernetes. Let's jump onto it. Brief agenda about today. We'll see why do we need multi-cluster. We'll see what are the problems are there in single clusters, and then we'll see the key challenges in multi-clusters. We'll see how can we transform our multi-cluster deployments using KubeSlice, and then we'll see how a packet seamlessly transfers from one cluster to another without using any gateways and stuff. And then we'll see everything using a demonstration. Before we jump into multi-clusters, let's just say that Kubernetes was not built in with multi-cluster functionality in mind, and there are quite a significant amount of challenges when all of your services and applications are hosted in a single cluster, and which opens a road for people to use several cloud clusters instead of one large, right? And I would like to go through few of the challenges. One could be vendor lock-in. It refers to a situation where a user is stuck to one cloud, and if desired, they cannot migrate or switch to another, and it potentially limits the flexibility of the clusters and also increase the cost. Geographical restrictions. So, as you all know that cloud computing doesn't allow us to make the need to know that where our workloads are running, but that is not true in some cases because there are few countries or regions where they do not want the data to cross the boundaries or also handle in a specific way, and that is not possible if you use a single cluster running in a specific area, right? Scalability limitations. So, in theory, there is this limit of 5,000 nodes in a single cluster, but we have seen practically issues if the cluster's nodes reach to few hundreds. So that is why scalability to an infinite number is not possible. And distributed nature of edge computing. So in edge computing, a local cluster plays a key role, where the local cluster process the data, send it to a remote cluster, and the remote cluster further process it, analyze it, and store it, right? And if that remote cluster is a single Kubernetes cluster, then there would be chances of network congestion, latency, and stuff like that. So as you see that there are significant amount of challenges, but these challenges further amplifies when it comes to multi-tenancy in a single cluster. So multi-tenancy refers to an environment where there are multiple tenants sharing a single shared infrastructure, right? And tenants could be anything like organizations, multiple teams within organizations, applications, services, anything, right? And Kubernetes itself has a soft construct called namespace, which provides a soft tenancy, but it itself leads to some issues, which could be one could be resource contention. It refers to a situation where multiple tenants are competing for a limited number of resources like CPU, memory, storage, and network bandwidth. And the risk of performance and all of this risk arises when this multiple tenants are fighting for the same resources. Another could be limited isolation and security. So when this soft tenancy is there could be a potential noisy neighbor problem where all those tenants are fighting for the same resources. And as you all know, there are RBAC access role present in Kubernetes, but as your cluster grows, managing those RBAC policies itself gets very complicated. So these are all the problems inside a single cluster. And considering for all these problems, the multi-cluster, it makes sense to move to multi-cluster. Using multi-clusters, the tenants can get a dedicated environment, you can get better isolation, better security, and all those issues which we discussed, you can overcome those. But walking on the multi-cluster journey itself comes with its own set of challenges, and two primary challenges are to bring synchronization between the cluster control planes and interconnecting those clusters using services, basically making these services accessible inter-cluster. And it's also important to build a robust or a strong solution through which we can make this services accessible to each other, right? Now you would say that these all problems we can solve with service meshes, right? Which provide with all these inter-cluster gateways and stuff. But these service meshes work amazingly at layer 7, but not at layer 3. And user assumes that there is a under this layer 7, network layer 7, there is a layer 3 running, which provides this connectivity through which you can connect everyone without any complex mapping, so on and so forth. But that is not true. First thing is it's really costly because of those proxies running in your application pods. And then there are cluster gateways which are costly, and also doing all these complex things, it's not a very tedious task. So thinking of all those problems, we built there's a product called KubeSlice. It is built by Avesha Systems, and it is a framework that brings both multi-tenancy and multi-cluster capabilities to Kubernetes by creating a flat overlay network to connect clusters. And that flat overlay network is what we call slice, and it is also analogous to a tenant. So as you can see in the diagram, it's a multi-tenant, multi-cluster kind of a topology where there are two teams, Zeus and Athena, and they want to share the clusters, which is Amazon and GKE, but also they do not want any linkage within the cluster, right? So a cost-effective way to get this resource sharing and isolation would be to create a slice. So the dotted line you can see is a representation of a slice. When you onboard your clusters to slice, you get these capabilities which are mentioned here in the left side. That you get multi-cluster connectivity, you get a flat overlay network, which is at layer 3, where one pod can connect to another pod seamlessly. You get service discovery across multiple clusters, and you get multi-tenancy. Right? Now that you have a brief idea about what KubeSlice is and what we are going to talk about, Rahul will take us to the deep dive journey. Thank you.
Right. Now that we have some overview about what KubeSlice is, let's dive deep into its architecture. Looking at it, I know it's quite overwhelming, but I'll try my best to explain each component. So KubeSlice is majorly divided into two major components, KubeSlice controller and KubeSlice worker. Right, so KubeSlice controller basically provides the central configuration management for the users and slices across the clusters. Okay, and in each worker cluster, there is a separate control plane up and running, which is known as KubeSlice worker. So the multi-tenancy and multi-cluster features of KubeSlice, you can use that using creating a logical boundaries across clusters, which is known as slice. So as you can see in the diagram, there are two slices in this. One is a green slice and one is a yellow slice connecting two different Kubernetes clusters. Okay. The slice router that you see here, right? The slice operator that you see here, right, is a Kubernetes controller which reconciles and watches that custom resource that is a slice. Okay. Now, the intra-cluster connectivity of the cluster still remains local to the cluster by utilizing the pod's CNI interface. but intercluster connectivity is achieved by creating the overlay network. So this is achieved by injecting one more interface to the pod. But I mean, still the intracluster traffic remains on the CNI interface, but traffic bound to external clusters will will flow through this overlay network, making KubeSlice CNI agnostic. Right now, the Slice VPN gateway that you see here, right? So when traffic moves from cluster 1 to cluster 2, the traffic is encrypted through these VPN tunnels. Right now, I'll move ahead and I'll come back to this architecture in a moment. I'm stressing on this word slice overlay network, right? What it actually is and how does KubeSlice creates it. So KubeSlice under the hood is powered by network service mesh. What network service mesh says it, welding your connectivity domain, which is your CNI, to your runtime domain, which is Kubernetes, is a mistake. All that you really care about is workload to workload communication, independent of where they are, right? So network service mesh is a layer 3 service mesh which runs orthogonal to your CNI. It actually does not harm your existing CNI, it actually runs orthogonal to it. It provides the workload to workload connectivity independent of your runtime domain. And it also actually works well with the existing layer 7 service meshes, that is Istio, Linkerd and so on. What NSM actually does is, it allows your workloads to connect to a new connectivity domain, which are known as network services. Right, so a network service endpoint is actually the one that basically represents that network service. Okay, now coming back to the KubeSlice architecture, a slice that we talked about is actually a network service, and a slice router that you see here, right? It is actually a network service endpoint that actually implements that network service. So a slice router is nothing but a layer 3 virtual device which is responsible for all the routing and forwarding rules over the slice overlay network. So let's see how a packet from app pod in cluster 1 routes to the app pod in cluster 2, right? So once the slice overlay network is being set up on both the clusters, right, you will have to onboard an application pod to a slice, right? So while you onboard that application pod to a slice, right, what we do is, we as in the slice operator does is, it injects the init container and a sidecar to that application pod where they are mutating the root. That init container is actually responsible for injecting that interface, while that sidecar is actually responsible for handling all the DNS related stuff. Right now, when an app pod in cluster 1 says that I want to send a traffic to an app pod in cluster 2, the traffic first goes to the router and app pod. As I said, router is a network service endpoint, right? Router then forwards the traffic to the gateway pod. The gateway pod here encrypts all the traffic, sends it to the cluster 2 gateway. The cluster 2 gateway forwards it to the router again on cluster 2, which then forwards the traffic to the correct destination application pod. Another important problem that KubeSlice solves is service discovery across clusters, right? So we took a feather out from multi-cluster services API defined in KEP 1645 in Kubernetes and introduced two new CRDs, service export and service import. So service export basically makes sure that the service in the cluster is accessible outside the Kubernetes cluster, and for each service export that you create, a service import will be created in all the worker clusters participating, right? Let's take an example here. Suppose you have a details and reviews services running on cluster 2 and you want to make those services available to the product page service running on cluster 1, right? What you will have to do is create the service export for details and reviews. The slice operator that I earlier talked about will reconcile those service export and create the corresponding service import in all the worker clusters that actually wants to consume that service. This is how a sample service export would look like. In the spec of this service export, you can see there is a selector, which is actually the same as the selector in any Kubernetes service. It will basically point to a n number of basically pods, right? When the slice operator sees that service export, it updates this status with the NSM IP and the pod IP of this application pod. Okay, and this is how a service import would look like. It would be very similar to a service export. In the status, it would contain a endpoint, basically the target endpoint. So another component that we have in our architecture is known as KubeSlice DNS. It is basically our own DNS implementation. It contains a core DNS plugin. Along with it, it watches this service import object. As soon as it detects that in the cluster that hey, this service import object is created, what it would do is it would add a DNS record of type A into core DNS. Now, DNS resolution in KubeSlice. So, the sidecar that I earlier told you, right, is injected to the application pods. It basically runs a DNS proxy server. So, what this DNS proxy server does is it proxies all the DNS requests sent by this application container. It fans out the DNS requests to both KubeSlice DNS and KubeDNS. Okay, the first successful response returned by any DNS server would then be sent as a response to the application container. Now let's look at the real world demonstration.
Okay. So now we have three clusters here. One is EKS, AKS, and third one is GK. We'll deploy the famous book info application on these three clusters, and we'll see how these services communicate with each other. So for now, EKS cluster is the controller cluster which we saw in the architecture, and other two are worker clusters. I have installed controller Helm charts already here, and also inside the other cluster 2 worker cluster. I'll just quickly show you. These are our Helm charts, right? And now what I'll do is, this is how a slice CR looks like. The kind is slice config, the name is Ravisha, that's a namespace, and then the spec which contains few configuration, and then you can see the cluster part where I have onboarded two clusters which I just mentioned, worker 1 and worker 2, which are two different clusters, Azure and Google Cloud, right? And then I have also this namespace isolation profile which says that I have to onboard namespaces on these workers on the slice, from these workers on the slice, and I have onboarded a book info namespace from all the clusters into the slice. Before that, I want to quickly show you that we all have this clusters CR also. So this is how it looks like. I have onboarded two clusters, and now I am going to deploy a slice on these clusters. Correct? Slice is created. We actually create slice config on the controller cluster, and then a corresponding slice CR gets created on the worker clusters. The slice is created. We'll quickly see the pods inside the KubeSlice system namespace. So these are the few pods. You can see these are operator pod running, few NSM pods, and then the router pod is running in the last, and then there are in the top there are gateway pods. So when you install a slice, you get a router and you get a gateway pod, right? I'll quickly show you the slice gateway too. It's created. Now I'll show you what's I'm going to create. So this is the famous booking flow app which has product page, reviews, details, ratings, 4 services. I'll install product in one cluster and other 3 in the other clusters. And without any gateways, Istio egress gateway, we'll see the connectivity. I am applying product page on Azure. Then I am going to apply ratings, review and details on the other page. Oops, I applied it in the wrong way. I didn't mention the namespace. I will do that. Delete this one. Apply it. And I'll do the same in other cluster too. Product. Okay. Yeah. Now, as Rahul mentioned, that we need to create service export if you want to expose some service inter-cluster, right? So we want to expose details, ratings and review, right? So I'll just quickly apply service export also for this too. I'll show you how it looks like. Yeah, I'm sorry. So this is how it looks like. Details, selector for the pods and then the port number. That's it. And then the controller will automatically update the DNS name and NSN IP in this series. Okay, it's running. I will delete this from the current namespace. And I'll check the service export status. Now a corresponding service import will be there inside the Azure one. Yeah, and the status is ready. So we'll see now. We'll open the product page UI. It's a node port service, so I'll use the node IP with the node port, which is 305 and 5. You see, it's here. So this is the detail service and the review service. So product page is accessing it with by creating service export only, without any gateways and stuff. Yeah, that would be it for the demo. Now I would just quickly want to know what could be the applicability of KubeSlice. So I would say there are many. I just mentioned few on the screen. Isolation for enterprise teams, where they want to run different infrastructure for different teams. Single operator for multi-cluster enterprise, which is a SaaS provider, where the SaaS provider owns hard tenancy for all of its customers. Hybrid deployment, let's say there's a database running in the data center for some compliance reasons, and the user wants to run the workloads on the clouds, right? Then they can use KubeSlice. Cloud hosting. So when the workloads are running on the cloud, but when there is a demand, they would want to use the data center also. And then the multi-cloud deployment. There could be many reasons for using multi-cloud. Let's say user wants to use specific services from different cloud vendors, and then they can use business. Yeah. Thank you everyone. This is a GitHub repo. Please check it out. You can reach us here also, KubeSlice channel at Kubernetes Slack, and this is our Twitter. Thank you.
Thank you.
In the service export, you were showing the DNS names, right? Can we do for the path-based routing as well? If DNS is not there, like in ingress, we use the DNS names, right? But if we want to do the context path routing, so can we do that also?
I think today it's not possible.
Okay. Yeah, I mean, there could be a chance DNS names are not there. We can, route the request on the path, right? So,
Right.
yeah.
Yeah, that is not possible.
Okay, thanks.
When it is a multi-cloud deployment or when you're configuring this, does it incur a cloud VPN gateway cost or anything there?
Cloud?
Because the VPN gateway you have to configure, right? If it is your data is getting transformed from AWS to Google,
but
right?
that is comparatively very less.
Okay.
Yeah.
The VPN gateways are actually the open VPN.
Yeah. It's just the new thing.
Hey, in the multi-cloud, you have shown the VPN tunnel. So, does it also take the parameters of IPsec2 kind of thing?
Yeah, it does.
It does. So, how does the IPsec work between two cloud providers? Is it?
I think today you have a option for defining multiple options, but if you don't provide it by default, we take the default parameters.
Does it support multi-region, like from US East to US West?
Yeah.
Yeah.
So
Your clusters could be anywhere.
Anyway, yes.
anyway, so in that case, like how VPN set up?
So VPN is actually per pair, right? So in one cluster there would be OpenVPN server, and in one cluster there would be OpenVPN client, and the certificates for those would be generated by the KubeSlice controller, which would come down to each worker cluster, and then the connection is established.
So in that case, like we do have separate name, right? Because one region the name will be something like U West, another region will be like US East. So it will flow through. Public.
No, yeah.
No, it's not a cloud.
It's not cloud
It's not
VPN.
cloud VPN.
Yeah.
It's our own VPN which we create, and certificates are ours, and like we just create a tunnel between the two things.
It's based on the slice name.
And how you guys are setting up the ASM?
Sorry?
ASM. For the VPN, we will have some asymmetric number, right, the unique one. So how you are tracking it? Like we need to filter out the traffic, right? So the packet is getting flown from pod A of container 1 to, cluster 1 to pod B of cluster 2. The traffic needs to be routed. Okay. So in that case, we need separate tunnel for each
pair of
Yeah.
clusters.
Can you show me the pod that gets mutated, or just tell like which containers you add and why? One more time.
Yeah. While you onboard the application to a slice, we have a custom mutating webhook running. It looks at the particular annotation on the your pod metadata. If that annotation is present, it would inject an init container and a sidecar. So
this is that CMD NSC?
So yeah, CMD NSC is that sidecar, and
Istio is also enabled for this namespace. That is why Istio proxy, and then the product page main container.
Scroll up. And that init container is the CMD NSC init.
Yeah.
Got it. Thanks. Understood.
So in the seamless, there is a slide deck, right? I am asking from here.
Okay.
So you showed multiple hops, networking hops. Is it adding to network latency? Because pod-to-pod communication, it has to go through a lot of routers, a lot of stops there, right?
No, it doesn't add latency because it's running at layer 3, right? So that is why it's comparatively faster than layer 7.
Okay.
Yeah.
So second question is, since etcd and your API gateway scheduler,
Yeah.
they're from, if I have a control plane from a different cloud, GKE
Yeah.
or AKS or AWS EKS, so how you consolidate all these into one?
Well, all it does is the slice operator that you see on each worker cluster, right? It has to connect to the API server of the controller cluster. So while installing the KubeSlice worker, right, you will have to provide the API server URL of the controller, and the credentials will be generated by the KubeSlice controller.
But is it a secure way of, because I am sharing all the control planes of different clouds with everybody else?
Well,
There are RBAC in place. Yeah.
the slice operator is not an admin, right? So it has the limited RBAC restrictions that it has been given.
Okay, thanks.
Limited and required role only.